Good evening. It's midnight. I've been trying to record this. My power keeps blinking and it keeps messing up my video recording. So, you see in front of you the All Squad non-profit page. Many of us are going to want to donate to those in need. Many of us have family members that are going to be affected by all these hurricanes. The All Squad is a nonprofit run by Ryan Hall, who is connected with anybody who's anybody in storm chasing, and all the storm chasers connect to him to provide forecasting. This is the best way to provide real help to people. There's a lot of YouTubers out there saying, oh, send money and we'll run down and deliver everything. You never know if it's going to get there. They are not a nonprofit organization. Every scammer in the world is going to be out there trying to scam people out of the money they donated. If you donate to Ryan, that money goes in many different ways. First of all, they're usually first on the ground because they're storm chasers. They get there before even the first responders get there. Ryan trains. Gives them first aid training, makes sure everybody gets trained. He makes sure they have first aid supplies in every storm chaser's car that works with him. Next, they actually have money with these storm chasers. If they're part of the All Squad, part of the donation team, they have money in their pocket. So if a tornado devastates an area, we get a hurricane like we did down in North Carolina, they have money in their hand that they can hand to people to go get a hotel room, to buy a tank of gas. Then they are bringing trucks loads of generators and the satellite systems down. He worked with Elon Musk this last hurricane in North Carolina to get over 900 satellite dishes out there for use at different organizations so that people could have internet access to let their families know that they were okay. So that the organizations would have a way to connect with donors and what they need, the government, to get what they need in their area. They also are taking down truckloads of generators, truckloads of diapers and food and water and different things. And they aren't just going to stop when the main rush is done. They're going to keep working with organizations to keep fulfilling needs. And that is a beautiful thing about Ryan Hall and all. And I want everybody, if you're going to donate, if you're going to put money in the hands of anybody, put it into Ryan Hall so he can make it sure it gets spread evenly, fairly, and in the right way. Because he does an amazing job with this charity. And he has to account for every penny. So it's not like it's not going where it needs to be. And he can pull up the papers to prove it to you. All right. We have had some questions about forecasting. Somebody wanted to know more about how I do what I do. So we're going to look at that. The first page we're going to go to is the solar dynamics. Now down here on the bottom, and this is going to be really important, this graph shows us what's on the backside of the sun. The positive and negative polarity of each sunspot. And it shows you where the big sunspots are. Right here is the 3250 or 3858 that's on the surface of the sun right now. We have a 2 or 3 day, probably a day and a half, 2 day gap, and we're going to start seeing those sunspots will be where it is. We should see those in the next day to know what they look like and have an image of them. The rest of this page, shows you your sunspots. These look at the sun in different wavelengths of light. And this is important so you can see where things are erupting. And this one you will find on NOAA. And I'm not going to dwell too much on this one other than to say you can see the coronal hole that is rotating in. It has gotten smaller, but this coronal hole down here is getting bigger. This is much larger than it was a couple days ago. You can see an activity, the sunspot that's erupting. There's one of the big ones. The black rolling is the satellite rolling. They're reconfiguring something. Some of these satellites should have been dead 20 years ago. The LASCO satellites should have been dead 20 years ago. These teams of working on these satellites are doing amazing jobs to keep very old equipment working. We need to give them a round of applause for that. I want to pay attention here to, this is called the heliographic view. And I'm going to back this up just a little bit so we can see it. And you can see some eruptions here, but I'm going to pause this and we're going to walk through it slower. We're going to start by looking around this area right here on the outgoing limb where 34, 33, and 32 are, or 42, 43, and 44 are. We have another sunspot up here. I forget the number on that one. We have a filament that is roping from this sunspot group all the way back into this area here that is not quite a sunspot yet, but it's a tie-down point. It's an anchor point. We have another filament here. We have some filaments here. We have a big roping filament reaching around to the sunspots on the back. We have filaments around here. This is a very active sun. We have a filament right here that's lifting off the sun, and it's huge. That's millions of miles above the sun, let me tell you. It's huge. Now, as we roll around right here, you can see one of the flares right there at 34, 33. It's kind of jumping through all the sunspots. It is a little bit aimed back at us because it is a horizontal flare. So in your imagination, you're going to draw an oval around that flare, and then kind of draw a cone out from the way that you think it's moving. This one I think is moving a little bit more toward Earth and is going to affect Earth. It is about a 12-hour flare along this region here. So here we are with that flare. There's a one that whips backwards. Now that bright flare is whipping back away from us. But then it unsettles. And you can see it travel right. Okay, there goes whoosh. Now that one right there is moving toward Earth. You can see it flare out. It's got a little bit of a curve to the forward. It might hit us, it might not. But it destabilizes the filament that is reaching around, and whoosh. Right here is a huge, huge eruption. It is Earth facing. It is going to be a direct hit. This is the big 12-hour storm that they have on the corona, and at the same time it's erupting, you can see that there's another big flare over on just around the limb. So this is massive, and it reconnects, forms back down. You can see the splash happen. Now right here there's another right there over around off the limb. This is not going to affect us. There is another CME and a release right there. You could see it break out. There is a slight eruption down here along 49, right down here at the bottom left. You can just see it moving. Whoosh, there goes something else. Little flare right there, little CME. And up here, there goes another CME off the 42, 43, 44 region. There's another little flare. You can see it. It's just around the limb. It's not going to affect us. It's too far around the limb. Now, here is a big flare whooshing out of 49 down here on in the middle, the lower middle one. That is moving earth-based. It's got a sideways whip to it. You can see it moving toward the side. Here is a CME. You can just begin to see it taking off from up by 48. Whoosh! There goes a big CME. Whoop! Flew it right off. But this one is moving off to the side. It's not moving directly out at us. It's moving off to the side. It's reforming that loop. And there is another tiny CME. That one is closer to being earth-facing. Over here on the far limb, on the northern hemisphere, there's another big filament eruption. Push! That one is not going to hit us. It's going to be too far to the left. Now, right here, if you're looking at 48, 48, right, the upper spot in the northern hemisphere, you can see it. Whoosh! See, here we go. Whoosh! That has a slightly northern trajectory. It is not necessarily going to hit Earth directly, but it will graze us. And it still stays very eruptive there. There's a little pop of light and a CME out of 49. Here comes some small CMEs out of 48 or 42 down here on the left or the right on the bottom. And we're going to come into satellite rolls. And as this rolls, as we come out, there is a major big eruption over there on the outgoing limb. You can see that CME reaching up and out and upwards from the sunspot region 3842. And here is a big flare. Now I think this flare will whip around and hit us. It's not going to be a direct hit, but I do believe we're going to get activity from it. It is massive. It had a massive CME with it. I do think we will get something from it. And whoosh! Over here in 3852, you can watch this huge eruption. It's just massive. It's going out the outgoing limb. Now that may give us a little bit of a graze, but probably not. And right here is another big CME eruption out of 42. Another CME eruption out of 42. Some little pops up there in the northern hemisphere. And another big eruption, a monster eruption. But this is around the limb. It is not going to hit us. It's not going to be directed at us. I do not think we will get anything out of that. Now, how do I verify this information? I've looked at everything. I've looked at everything I see on the sun. I know where it is now. I know where things have taken off from by watching the feet of the sun. Now let's go over here to SOHO, our Space Weather Live, and we're going to look at LASCO 2 and 3. And LASCO 1 is gone. Okay, that was on the outgoing limb. It died. These are 20 years past their due date. And they're holding these things together with chewing gum and Band-Aids. And they're doing a remarkable job. These scientists that keep these satellites working. This is a feed. The sun is over here dead in the middle on the right. Anything moving along that middle line to the right is going to hit Earth. A lot of this stuff is coming from the far side of this satellite. So this satellite sits off on our incoming limb, and it's looking at stuff that is just coming around the limb. So when we see something like this, it doesn't mean that the middle of the sun is exploding necessarily. It could be the far side of the sun exploding. And look here, we have a great big, huge, massive eruption, but it's coming from the backside of the sun, from the parting regions. And I'm going to back this up. Here is that big solar flare from 42 and that region there. That massive flare there at the end that I didn't know if it was going to hit Earth. Now you can look at this and say it might have a trajectory that is going to be, or a component that may be moving towards Earth. Keep in mind, it also could be flying in a cone out away from that eruption. But it's wide enough that it may have circled back. It's very hard to look at a flat picture and get a 3D environment. So they've had this big explosion. Here is another big eruption from some of the stuff on the back side or the far side of the sun. This was one of the ones that I'm very thankful that did not hit us. These last two flares are too big. They would cause power disruptions. They would cause satellites to be lost. They would cause internet disruptions, problems with cell phones. And that is the last thing we need right now. We also do not need these big solar storms like this to be hitting Earth with the hurricanes we have. It will strengthen those storms. It will feed energy into our atmosphere, and it will cause mayhem. So be thankful and give thanks tonight that these two did not hit Earth. Okay. So now we know this could be hitting Earth, but how do I know if it's coming from the middle of the sun or the far side of the sun? How do I know? Well, we're going to come over here to Lascaux 3, and Lascaux 3 is sitting in front of us. So anything that comes all the way around the disk like this is directly coming at us. If it's off to one side or the other, like this is kind of off to the side here, then a lot of that is going to miss us, but some of us can hit it. If it's moving way, 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 way far down, then it might be a miss. It might go underneath us. And if it's way high, it might go over the top of us. Okay, right there. That is about as dense a flare as you can get. That is so massively dense that it's graying out. I think this is one of the ones that's going to maybe graze us, but not directly hit us. And here's another one. Tense eruption, second one right there. Whoop, it's going to hit us. These are so dense. Thank God they're moving slowly. They're well under 1,000 kilometers per second, because if they were faster, they would do harm. Now we have that one that's going out the side, another big one. And whoosh, this one is going from the back. Okay? This one is the one that's aimed away from us. It's not going to hit us, thank heavens. But it is going to send particles our way. And sometimes with these storms, so you understand, it's like dropping a stone in a pond. Well, it's like an atomic bomb. You know how the bomb went up in a mushroom cloud, and that was the exact impact area. But after it exploded, there was a massive wind that whipped around everywhere around that area and caused radiation poisoning. Think of it as this is the blast zone, but this is the impact area that the winds from that explosion caused damage. So these big things on the backside of the earth, these kill shots, can have such a impact blast that it will whip around the sun and get us on this side of the earth. It is possible. When you see snow like this, you know something has hit the satellite. Doesn't mean that storm has hit the satellite. Could mean a storm before it hit the satellite. But something has hit the satellite when it gets snowy like that. So, the next thing we're going to look at is the flares. The flares, if these are long duration, like this over here that lasts 12 hours, those had multiple CMEs, multiple M-class flares. It had lots of stuff coming at us. Whereas this little bitty X-class, 1-class flare, while it's an X-class, it's very impulsive. It's very short-lived. It's very quick. It more than likely did not at that time cause a CME at that time. Then we have another slightly less impulsive, little bit wider M-class flare. This is probably that big flare that happened, boom, 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 was very quick, but there wasn't anything with it. But then afterwards there was a CME. So how are we going to verify that? That was just before 1600 hours, UTC time. So now we're going to go over here. And it happened probably right about, well, it would have been, I'm going to guess it's right here. There's one of the flares. And it's far away, and we really can't get any detail because it's too snowy. One of the other big flares that happened was this one. It was from 48, so from right here in this region where the hand is, there was a big arm of that was super dense plasma that reached up like an arm and which whipped out just past us and above us. So I don't think we will get the direct impact, but if you look at this, we have stuff moving all the way around the halo and in very good detail, so it's somewhat dense, and this could be because we have a coronal hole streams coming at us. And these could be, you could have the blast zone and the coronal hole stream coming at us. So maybe you'll get a big push to some of the wind from the blast radius, but you're not going to get the main event. You're not going to get the impact from the zone, but you're going to get that radius blast, and that may pick up the particles that are already out there and pick it up and move it faster. And I'm going to pick on Becca. She's my right hand. I love Becca, but you know, sometimes Becca likes to be a pill. And so picture she's at the end of a ping pong table and we're standing at the other side. We've challenged her to a game of ping pong, and being the little devil she can be sometimes, she picked up a box with 1,000 ping pongs in it. And she just hurled that box forward, and all those thousands of ping pong balls are flying at us. And they're going right, left, up, down, bouncing off each other. Some moving slow, some moving forward, some moving backwards from bouncing off another particle, some moving really fast. In your mind, I want you to have that picture in your head. That 3D picture of all those ping pongs going in all those different directions. That's what it's like between us and the sun when we have this many CMEs. It's very hard to predict what's going to run into what's going to scoop up what, and what you're going to look for. This is the part of the science that most of those media people that are raving we're going to have this big storm don't understand. They don't take the time to look at it. They're just parroting what they're told to parrot. And the person that told them that may not understand that science either. So they're just telling you there's a chance. it's up to you to look at this and go, okay, I see a really strong component whipping up this way. And this may or may not be moving toward me. It could be moving off the back, which it was. If you remember the last go, there was an arm that went up and a blast that went to the back. So this loop is moving backwards. This stuff is moving forwards. And there might be a push because that came from right here. There could be some radial winds that are moving faster. This is how you have to look at that to figure out all those ping pong balls. The other thing you look at is like here. You have, and we're going to look at this. So this one was a 12-hour blast. It was at 29, at the 29 angle, which you count backwards in an angle from counterclockwise. So you go back to 9 p.m. or 10 p.m. and count around that way. This one right here, we know is that upwards reach in the arm. It's clear up in the 1 o'clock position, very close to midnight. It's between 1 o'clock and midnight, in there, and it's not going to hit us. Its width, or its girth, was only 90 degrees. So it's 90 degrees, probably from 11 to 1, and it's moving up and away. Then we look at the median speed. This is the median velocity that CME is moving, measured in kilometers per second. Now, a reasonable CME that's moving at about 1,000 kilometers per second can reach Earth in 36 hours. If it's moving at 2,000 kilometers per second and aimed at Earth, it can hit in 24 hours or less. Typically, we don't get ones that big, thank God. They're very rare. There have been some as fast as reaching Earth in 8 hours. They were super big eruptions. You have to look at this wind speed. And as you can see, most of these are between 100 and 500, maybe an occasional. This one is 1,000. It lasted for 3 hours. It's over in the 1 o'clock position, probably behind the sun. Probably not going to do much damage. 1 o'clock, 2 o'clock position right there. It probably isn't going to do much damage. This is one that was probably moving more outward and backwards. Always look at your median wind speed over here. They're hitting between. It gives you the best estimate. I very rarely, unless I can see that that's a very strong eruption count on this high number. And here is our one that I told you to watch the filament rip away. It was huge. Where is it? It was right here. There's that upwards blast with an arm. It's reaching up and away. Where did it go? I know that was strong. Right there. Okay, this is actually what should be where the halo is. This is a full halo hit. The other part was the start of this, but this is the bulk of that eruption. When it reached the peak of when it's being hurled away. This is super dense. And it's going to cause a lot of auroras because it is moving towards us. And we have a signature here, but we have a blast kind of moving this way, we can tell. And then we have the solar wind that's moving around the far side. But the blast is by far, looking at this, going to be moving ahead of us. While it's a full halo and it will hit us all the way around, The bulk of it is moving off to the front of us. On our outgoing limb, it's moving past us. That is how you use this part of that website. And you have to go through and look at each one of these storms and look at go back and verify it on SDO and know where each and one of these CMEs took off to figure out whether it's front, back, and then you use your Lascaux to verify it. We had a question about sunspot numbering. Each sunspot, as it rolls in on the incoming facing Earth disk, is given a number so that we can identify which sunspot is putting out which activity. As it rolls around behind the sun and comes back around, if it lasts that trip around the sun, it is given a new sunspot number. But it may be an old sunspot. Here on the disk, excuse me, I apologize. Each sunspot is given a classification. I'm not going to read through this because I'm trying to keep this very short. But if you hit that question mark, it's going to bring you to a page that explains all of it. And if you don't understand what they mean by umbra or penumbra, go look it up. Understand what they're saying to you. Look it up so you're learning the science. Over here, these are sunspots. They classify the sunspots in different ways. By the configuration of the number of spots in the way, like this one is a mirror image. This is very irregular. This is even more irregular. They're different configurations. Then they look at the size of the largest sunspot in the group and they measure it. And they give it a scale. And then they look at the distributions or how those sunspots are put together. Are they crunched up close together, where the polarities are crushed together, or are they not? Underneath this is the diagrams that are going to tell you what each one of those means. Looking down here, 42 is way over here. It's off that incoming limb. It's not going to hit us anymore. 3848 is very definitely getting more magnetic. It is changing shape. It is back up to beta, gamma, delta. This means you cannot slide a piece of paper in between those polarities, and they're bumping into each other and more likely to create a CME. .49 is not. It's only a beta, gamma. It's not as eruptive as the other one. You can kind of get more of a separation between the blue and the red. Its probability of it is down. Now, the thing I want to impress upon you is over here in protons. This had a huge CME. They're giving this a 99% chance that will create light protons, that it has the helium, it has the molecules within its CMEs to create auroras when it gets here. .51 is fading away. 52 is hanging in there. It hasn't really grown, but it hasn't really shrank. It's still hanging in there. Our coronal holes, this has gotten larger down here, and we're getting a secondary sunspot behind it. And this has gotten a little bit smaller since 3 or 4 days ago. But these now are earth facing and will be affecting us in a couple of days. So a lot of, in the cactus, a lot of the wind that's moving all the way around the halo will be coming from these corona holes. So you want to pay attention to where, like, going back over here, you see how this is going? This is the CME right here. This is the solar wind and a remaining blast from a past CME. So this is moving away from us. That is moving back. This is coming at us because it's a nice steady wind. And that's how you have to look at things. Real-time solar activity. This should be bookmarked and on your phone. Where you see the line that says Earth, that is what is happening right now. The ACE MAG satellite is out in front of us about an hour, give or take solar wind speeds, 30 minutes to an hour and a half. So what is hitting it shows up in the graph beyond the Earth line. So this is what is coming at us that has hit that satellite and will be inbound into Earth shortly. Usually not more than an hour and a half out from Earth. So density, speed is, kind of holding. It's going to drop and then pick back up again. We have a huge spike here coming in density. It's going to be very brief, and then it's going to fall away. So this is a sudden onset spike. It's going to be huge. BT, not so much to worry about. We are at a very low negative number. That means we're real close to midline. If it's in the green, we won't see it unless it's a super big storm. If it's in the red, we'll see it. And that's how you read those graphs. And you should keep that on your phone because it's going to tell you, maybe you shouldn't leave right now. Maybe you should wait because there's that sudden on-site spike coming. Looking at the aurora forecast, this tells you what is coming or what they think their timing is going to be. It's good to use this as a guide. But again, NOAA and NASA are only right half of the time because it's very impossible to get everything right and perfect every time when you have so many storms going in so many different directions. And you have corona holes, and you have this and that and the other thing. So we're going to look at long-term forecasts. They've dropped the 10th through the 12th to just a very minor storm. Pretty accurate, I think, because I think a lot of this is moving away from us, not at us. But we are picking up on the 22nd and the 26th. That is new on the 26th. And we have some very large sunspots that should be around in about 6 days. So if we're at the 9th, it'll be around the 15th. We should start seeing those big sunspots rolling to center disk. And then if they're flaring, they will pick up in this region. Remember, a long-term forecast is based off corona holes because sunspots are not predictable. Sunspots we can only predict, as 8 minutes to 36 to 48 hours out. There's not a lot of lead time. But you can use this, like we know that we had this very active sunspot, and it was erupting on the 7th. So if I take 3 days away, next week I'm going to look and see what's happening on the 4th because that sunspot's going to be back around to me. And they may give it a higher percentage of eruptivity based on what they think it's going to do. So, if I've answered all your questions and you enjoy what I do, I don't get paid to do this, and I'm doing this for free. If you appreciate this, I'm going to ask that you come over here to our North American art products. And I'm going to ask that you at least share it with people. Please share it regularly so people get to see it. We have a Facebook page for North American art products. Join the page so you know when we have new things coming out, because I put a couple feelers out there. I think I'm going to create some new tennis shoes because I like those pumpkin colors we got in the last storm. But anyway, I'm not somebody that begs for help. And most of you don't know me. You do not know what's been going on. For the last 4 years, I've been battling complex regional pain syndrome since the hip replacement went wrong, and I got COVID following the hip replacement. It damaged the nerves in my leg. It makes it dangerous for me to walk outside. One expense that is coming up, and I'm trying to get grants to cover, but we may need to raise some money for, is a mobility device called a terrain hopper. And it will allow me to go over logs and rocks and through water and through sand and through snow. It gives me headlights. It gives me a place that mounts my tripod right to the rail of the machine, and I never have to get off it. I never have to risk falling in the dark or stepping in a hole and breaking my hip, which I have dislocated my hip. It's not a fun thing to do. It's extremely painful. I'd rather have 6 kids at once. But we have that coming up that I need to be able to afford to get me safely out there, and so that I can travel more. I'm very limited on where I can do, and right now I've been mostly shooting from the car, so I'm not getting the shots I want to get. Also, my roommate's dad died. His mother is selling her house down south, and she will be moving up probably this spring, and I have to move out. I cannot find an apartment here in town. The waiting lists are 5 years long. So I am opting to go van lifing. And we need to raise some money to start getting that van life, that travel van. And those are not cheap. But the upside is I'm going to be out there all year long, traveling around to different lighthouses, different areas. More of you will get the opportunity to meet me if I'm in a van. I will have better opportunity doing it that way to hold mini classes, so that if a bunch of you want a class, say, over in Lansing or St. John's, you can arrange a spot for me to come down at somebody's house and I'll teach. And we can do it in small groups, and that will be much more effective and than trying to organize a huge class and put the expense of trying to come up with money to rent a hotel, money to rent all these facilities, not knowing if anybody's going to take the class. It's more than what I can handle doing on disability, which is why I have not been teaching. Living in the van will put me where I can be where all of you are. And more of you will have an opportunity to meet up with me and get to know me and get to learn from me. So, please, help me out, because I can't do it without your help. At least share the page. If you have the money and can afford to buy something, great. If not, make sure you're sharing this, because somebody you know will want something. And make sure you're giving me feedback. If you think of an idea I don't have, or you want to see a product that isn't here, mention it to me. I might be able to make it. And the plan is that over the next couple of years, I'm going to be traveling to all the different lighthouses, trying to get all the different lighthouses in with dark skies, or storms, or maybe sunsets. In the wintertime, and when it's too cold to stay up here in a van, I plan to go down the East Coast and start doing the East Coast lighthouses, working my way south. And I'll spend January and February down where it's a little bit warmer, and do lighthouses down in Florida, Texas, the states down there, so that we have a wider selection of lighthouses to choose from. And along the way, I may take some trips out and go photograph, a moose, a bear, waterfalls. You never know what I'm going to come up with. But that's what this is about. It's time to reconnect with myself, get back to my art that I've had to put on hold, and get back to all of you. So please share.